Good morning. My name is Briana Garcia, and thank you for joining me today on the Global PropTech session about smart and healthy buildings. We do have a Q&A section, so I'm going to try to be mindful to essentially make sure to look at it to answer your questions. But if not, I will be happy to answer your questions also at the end of the webinar. So thank you for your time. I'm going to give people just another minute or two to log in, as I know, how things go and how life is. So just give me one moment. But while we're waiting, if anyone's got any questions, by all means, I'm here to answer them. All right, since we do have a presentation, I'll go ahead and get started. And as mentioned, if you've got questions either during the presentation itself or at the end, let me know. I'd be happy to answer them. So today we're going to be discussing smart and healthy buildings with the Internet of Things, of which we'll go into. To begin, my name is Briana Garcia. I am here in New York City, and I've come to work on global PropTech issues, if you will, through a variety of my career backgrounds. I actually was an environmental consultant in Southern California, where I advise on different water projects and water management plans for different commercial industrial job sites. So it was always great going on a job site and helping everyone figure out what's the best way to mitigate pollution. And technology was a huge part of that. After, I went and got my master's degree at Columbia University, where I focused in on sustainability management. And that is a pretty broad term, but for our purposes, it was a mixture of finance, science, policy, and a little bit of technology. And then after Columbia, I went and worked at the World Economic Forum. And there I was essentially a project coordinator for their global water initiative, which essentially is using technology as a way to enhance what we call the Sustainable Development Goal number 6, which is water and sanitation. And so after the World Economic Forum, I went into tech as I saw it being the best way to essentially address our sustainable development goals. And so long story short, here I am, but we're excited to discuss how IoT is going to be working with smart and healthy buildings. All right, so we do have a brief agenda, and we're going to start off of, what is the Internet of Things? We know it's a hot ticket word, so actually, what is it? And then we'll go ahead and go into the smart and healthy buildings, the definition, benefits and examples, and also how can you implement smart technologies in aging infrastructure, because let's be honest, we all live in cities and old buildings are here to stay. And then we'll go into a case study that we're currently working on, and also connectivity. So we're very excited, so let's get started. So what is the Internet of Things? It's essentially this concept of connecting the physical world to the internet. And that can be anything from, as you see in the pictures, information from your toothbrush to your phone about how much liquid is either in the device, or if you have a smartphone or a smart watch, essentially, that is also a way to figure out, what your body temperature is, what your heart rate is. That is the Internet of Things. So you have a device on your wrist, and it's sending information to a cloud service, and then that cloud service is doing some analysis and giving you the feedback right there all the time, so you know exactly what's going on in your body. So these are just examples of how the Internet of Things is already working in your life. I happen to work for a software company called Temboo. We are based in New York City, and essentially we are data aggregators at the heart of our purpose. We're able to take information, maybe it's from your smartwatch, maybe it's from sensors deployed in a building or machines, and aggregate all the data so that it lives in one platform. Essentially, you can have data from 10 different sources all on one software platform or one login or on your phone. So basically this interoperability, or this ability to aggregate all the data is what we do really well. And we're really excited about it. So let's talk about you. Europeans spend up to 90% of their time indoors, and us Americans, we spend 87% of our time indoors, another 6% in enclosed vehicles, which essentially means we're inside a large majority of our day. And if you're going to be inside somewhere, like let's say whatever building it is, you have to make sure that it's it's going to be comfortable for you, right? So just talking about our day-to-day lives, this is quite important. And so this is where we're going to get into buildings, and then we're going to talk about data, right? So we keep asking ourselves, your smartphones, your iPads have this operating system. Why doesn't a 2 million square foot building have an operating system? And why is the data that we collect every single day simply gone? And it doesn't have to be, right? Information is always being collected essentially about a building that we can use it and essentially enhance our lives. So this is where IoT really comes in as far as benefits. So IoT allows you to take information from a cooling and heating system, a water usage system, security, ventilation, and energy, and essentially puts all these puzzle pieces together so that you can really see this holistic understanding of what is going on anywhere. It can be buildings, it could be a utility, it could be a water system, it could be transportation, it could be health and medical. All these bits and pieces of information always exist, but until you start to really piece it together, then you're always going to be missing some downfall or some room for improvements that can be made. So what data collection is, or what we do really well is we, again, take information from various different sources, and we're able to optimize it and put it all on one platform so you can see everything. And not only are we optimizing the operational efficiencies within buildings, we're also looking at the sustainability of things. Again, sustainability, I know it's a hot ticket word, but it can mean a lot of things. And for our context, sustainability essentially means having information that can increase the longevity of whatever asset it is for generations to come. I mean, my old building in New York City was built in 1920, and it is not going anywhere. Neither are there 5-story walk-ups. But that's really important, is that you have the optimization for the sustainability of whatever you're trying to manage, if you will. And then again, there's that wellness piece. If you spend 90% of your day indoors, you want to make sure that the place that you're working at essentially is taking into account to your needs, be it maybe it's too hot, maybe it's too cold, maybe there's not enough lighting. These little bits of information really can make an improvement. So at Temboo, again, we collect data and we give it to you on one platform. It's very easy to see. And so before we go any further, we're just going to talk about quickly the IoT architecture. So IoT in itself, again, is the information of things. There are a lot of things out there, but just as a blanket to see how things go, essentially what we would do is we would have these sensors, as you see this NCD sensor over here. This sensor is taking in information about the physical world. It could be temperature, humidity, it could be water levels, CO2 levels, it could be anything. And these sensors send information to this microcontroller over here. This microcontroller in itself is about 3 by 3 inches in dimensions. It's essentially a small computer. And that microcontroller allows all the information from the sensors to be sent to the cloud. And for that cloud, we are a cloud service, is what you see the graph at the bottom. So again, information comes from the sensor, from the physical world, gets sent to the microcontroller, and that microcontroller, what we call a gateway, sends that information to the cloud. And then we're able on the cloud to do all the analysis that you see. Here we've got voltage, and you can see the different predictions for 60 minutes, 24 hours, 7 days, a month, 3 months. And then we can get more into it as far as using machine learning algorithms for predictability and predictive maintenance, which is really when information data it becomes really neat as far as insights. So again, sensor data to microcontroller. That microcontroller, again, is a miniature computer. You can essentially build a computer if you wanted out of it. You can put a keyboard and a screen on it. It would work just fine. Or if the laptop that you're watching this webinar on, if you were to take it apart, you'd see a microcontroller in there. And then again, that information then gets sent to the cloud service. For us, we are a cloud service, and that is Temboo. I'm also just gonna, again, if you've got any questions, by all means, let me know. I'll go ahead and take a peek at the Q&A every now and then. All right, so why should you care about IoT and smart and healthy buildings? Well, again, not only do you spend majority of your days in building, but there's also a huge financial payback. So here in New York City, at 345th Park Ave, the first year that they implemented IoT technologies, they saved almost $980,000, which is quite a bit of money, right? And at 560 Lexington, which is a smaller building, they were able to save $1 a foot. Now, if a building has, oh my God, 80,000 square feet, $1 a foot, now we're really working with something. And, for bigger buildings, you can save an enormous amount of money. So the financial paybacks are quite immense. Sorry, I just have a quick question. Are your sensors battery powered or hardwired? Pros and cons of each. Great question. Depends on what sensor that you do. So we are a software provider, so we actually don't manufacture any hardware pieces, and which is for us the preferable way, because we can work with a lot of different manufacturers and have different hardware from different sensors companies. So you can it doesn't matter what brand it is, essentially, it can all live on our platform. But battery sensors, we can do battery sensors depending on which sensor. They can last anywhere. It depends on the sensor and how often you want data essentially sent to the cloud. So if you want data sent once an hour, that battery sensor could last you 5 years. If you want data sent to the cloud every 30 seconds, that battery might last you 1.5 years. It also depends on the conditions that you're working in. So if you're working in a freezer or refrigerator to monitor the temperatures in restaurants or butcher shops, which we do work with a major bakery in New York City, that will essentially keep the lithium battery alive longer. So we can expect that those wireless sensors will last about 2 years, so which is great. We also have hardware sensors. Essentially, they can live in a wall, just plug it in like your phone when you do at the end of the day. They can live there for 5 to 7 years. So really the technology for sensors itself has come a long way. Pros and cons of each, I would say, obviously pros, you don't really have to worry about the battery too much. For the hardwire, the cons, I think it depends more on the connectivity of the sensors, and we'll get into that in a little bit. But I mean, we've come a long way as far as advancements, but those are some battery and hardwire sensors. And I'll be happy to send some links to some of the hardware that we do use afterward, if that helps as well. Okay, let me just, let's see, I'm just gonna exit out of the question and dismiss. Oops, sorry, I'm just trying to, again, exit out of the question. Let's see, one moment. Okay, well, we can move on. So some of the benefits of having IoT in a building management system. One is the critical data insights. Remember, IoT gives you the power to have information from your water pump system, from your lighting system, from the temperature of either floor, and by being able to put all these pieces together, that's really where you can see, okay, this HVAC system on the 3rd floor is broken. I need to go fix it because that's where majority of my energy usage is being depleted, essentially. And we'll go into all of these key benefits in just a moment. Predictive maintenance. As mentioned, once we have enough data collected, especially on a bigger machine, we can run a machine learning algorithm to figure out when it's going to break beforehand, which is really essential, especially for utilities, which we'll get into a little bit more. Also reduce the usage of resources. So we can use, oh, thank you. Sorry, there we go. We can reduce energy and water resources in building with IoT management systems. And we all know about the water energy nexus. So if we're able to really pull back on our resources that are just being expended at any cost, we can really start to reduce greenhouse gas emissions, which there we go. Now we're fighting some climate change, meaning a lot of global studies goals as far as GHG and again, climate change initiatives. Again, monitor and detect air quality. This is a huge aspect of information that people are essentially looking for. Which we'll get into, increase services and profits. So again, for major utilities, for bakeries, for transportation, it's all about service and building that trust with your customers. So if you can improve that and lower your costs and make money, now we're talking, right? And again, the holistic understanding. I think this is always key no matter what you're doing. As I mentioned, I was a water consultant, and having all of the data pieces for my water system was always very hard to come by. Majority of the times the data either didn't exist, and if it did, it wasn't clean, it wasn't useful, and it just essentially was dead data, if you will. And lastly, is help decision makers make evidence-based decisions, right? If we really want a smart and healthy future for ourselves and essentially the buildings that we work in, we need the managers and positions a power essentially to be able to see this data in a way that makes sense for them, so they can actually say, you know what, let's not go with option A, let's go with option B because of the long-term payouts. So we'll get into these. Also, IoT benefits for occupants in buildings. Not only monitoring, ingesting building systems, but you have HVAC systems, lighting to match comfort levels, right? You can also have real-time security and surveillance services that enhance safety for all the people in buildings. And then you can also have, again, predictive maintenance to avoid outages or significant downtime caused by maintenance issues. So we have the benefits for the building managers, and then we also have the benefits for the occupants. So proactive equipment maintenance. This is, again, huge for utilities and also building managers alike. So we can essentially use IoT as a way to figure out when machines are going to break beforehand. And essentially, let's imagine you got a major water pump system at the bottom of your building. You need it for every floor. It takes care of everything. And essentially, after having about 2 to 3 months of data, we can essentially run a machine learning algorithm that takes in the information. I'll answer your question in just a second. Takes in the data and it says, okay, Brianna, in 4 weeks, this water pump is going to break. And we can tell because there are anomalies in the data, it doesn't have as great as output as it used to, and it's taking up more energy. So in about 4 weeks, it's going to break. Great. Now I know that I need to, 1, order a new part. 2, I can look at my subcontractor schedule to figure out when I can have somebody come to my building and fix it. And 3, I can do that week 3, let's say. And now I've got a whole week for this person to actually take down the machine, fix it, and then continuing its essential functionality. Conditions-based maintenance, we just kind of spoke about that. And then reduce downtime. Downtime is essential. Anything that's down essentially causes a lot of issues. It stresses other machines in the buildings. It also is a lot of money wasted. So a lot of the people that we happen to work with, be it a smart building context or even bakeries or, again, utilities, it all matters. Downtime is huge. And that's the one key thing that we really try to mitigate through our technology. Okay, I'm going to answer some Q&A real quick. Do you need to have a building management system to get the benefits of IoT? Because a lot of smaller existing buildings don't have a BMS. That's a great question. You actually don't need to have a BMS system. As mentioned, or I'll go back to the sensors in a little bit, but you can essentially have any sensor attached to any machine. So if there's something you really want to know about your building, we can find something to take in that data from the physical world and send it again to that microcontroller or a gateway. And that gateway then sends the information up to the cloud service, which is us. And then we run the agnostics and analysis and send it back to you on your phone or on your tablet. And we're not the only ones that do that. There are tons of other companies that do, but I think we're the best. And so no, you don't need a building management system. You just have to have a very clear-cut understanding of what you want to solve. If you want to reduce your energy usage, okay, let's figure out what each floor is using. If you really want to go a step further, you can do sub-metering for apartments. If you're looking at a corporate building, there are ways to essentially have, let's say, a sensor in a room that essentially is counting how many people are in the room and how many people are out of the room. So there's nobody in the room that lights automatically dim. And that's a great way to save energy, because how many of us have been in these huge corporate buildings and the lights are on 24/7? It's not sustainable, right? And again, for the smaller buildings, no, the answer is you don't need a building management system. You just have to figure out what you want to solve. You can find a sensor for it, and then you can start to get the analysis that you'd like. So if you want to let me know even after the presentation which data problem you'd like to solve, I'd be happy to chat about it as well. And that goes with anybody. Okay, let me get out of the question real quick. Okay. Again, you can optimize a building environment for comfort and productivity, because how many of us have actually worked in a very cold building that's too cold and you can't actually focus? I know I have. I don't know why it's always that cold, but essentially you can always optimize it for everybody. They're just understanding basic conditions that you're working in. If you're obviously more comfortable, you can obviously have a higher productivity rate. There are tons of studies that actually confirm this as well. I don't know if we necessarily need a study for that one, but yes, there is literature. There is literature that does confirm that. Great. Just because it's hard to get other questions. And then less turnover, right? If you're happier working in a location or at an office, then yes, you're probably going to stay there. If it's freezing cold every day, you have to wear a jacket, then probably not. Okay, let's talk about safety. So there is a community in California, and they had a major gas leak issue. And essentially, we could have used, for example, IoT to solve this, right? And just globally speaking, there are about $30 billion lost annually due to gas leaks. And IoT can save about 18 million, at least in the US, if not more. Right, and essentially is one, no one wants gas leaks, but two, if we have sensors at each one of these elbow joints or at backflows, we can figure out how much pressure, how much gas is actually being run through those pipes and how much we're actually losing. And if we are losing gas, let's say, we can have a text message or an email sent to the building manager itself to figure out, hey, you know what? We do have a major gas leak. We have sensors going off. Methane levels are high. You are now being notified, and then you can even have us go a step further and have our software essentially say, okay, not only have you been notified, we can actually go ahead and shut off the valve itself, which is really great. And that's what we call remote control or an actuator function feature. And so really IoT is not only about getting data from the buildings that you currently work in and what floor you're on, but it's also about the safety of your lives, right? And that's real-time leak detection. So we can have data sent to the cloud once a second if it's a high priority or a dangerous chemical that you're monitoring, for example. So again, methane gas detections, alert systems, which is, again, just talking about human safety when it comes to monitoring different things. And then again, cost savings, as mentioned, the building here in New York City saved $980,000 just by looking at IoT and how it connects to their systems, waste reduction, again, water, energy, you name it. You can also have green roofs. You can have water being collected and saved, and you can have water levels being triggered, so it needs to get filtered. And when there are essentially there's so many creative ways to use IoT, which is really exciting. And then again, the environmental impacts. So lower GHG emissions, that's a huge goal of everyone in any country and any city. So by 2050, 2/3 of the world's population will be living in cities. And it's quite immense when you think about how many people that actually is. Cities take about 3% of the total surface area of the planet, but you've still taken over 90% of all the natural resources. So really having a place where people can not only live, but work in a happy environment is absolutely essential. And also buildings around the world are trying to lower their GHG emissions. So here in New York City, our existing infrastructure accounts for 70% of all of our GHG emissions, which is quite immense. We also have a very aggressive GHG emission initiative called the Clean Mobilization Act. Essentially, it's requiring all buildings above 25,000 square feet to reduce their GHG emissions by 40% by 2030 and by 80% by 2050 to help us meet that goal. It's called 80 by 50. So really, it's going to come down to bits of information coming from the top of buildings, how much energy is being saved, how much water is being saved, what is actual levels of, you know, methane, CO2, it all comes together, and IoT really gives you the ability to do that. And then, in my opinion, a connected world is a sustainable world. So we're excited to be part of this and to started to work on a smart building project, which I will show you at the end of the presentation. But existing infrastructure, we need data, and IoT is a great way to do that. Okay, data visibility and insights. So a lot of people also have to report their data, which is huge. Also, IoT gives you the ability to have not only the structural integrity, but automatic data reporting. So for building managers, you need to have how many kilowatts you've used, how many megawatts you've used. If you've got a solar panel on top of the building, you need to know how much data is essentially coming from that decentralized microgrid being sent back to the main grid. So really, IoT gives you the way to automate all this bits of information that are essential, that are key to many key roles for regulatory purposes as well. IoT just, you know, it makes your life easier, and that's the goal. And then how can these, you know, technologies be implemented? We kind of went over a few, but we can also get into the processes under buildings. So water supply systems, chiller plants, which essentially chill water, AC and heating systems, which take up huge amounts of energy, electrical loads. So we can essentially figure out during peak time when other buildings or when these buildings can use different resources to offset that. And then connected weather systems as well. So we can have micro weather stations in different areas tell you, okay, it's gonna be 74 degrees today outside, let's set the building to this temperature. And really, you can really start to manage it, right? And almost micromanage it to a degree. Also, how can these technologies be implemented as far as the building? As I mentioned, lighting systems. So again, I know I've been in buildings where lights are on 24/7, and it is immense when it comes to energy usage. So you can always have buildings or have rooms essentially automatically dim when there are no occupants in the room. Also, you can have AC turned off at different parts. It just really depends on the data that's coming in. That's for room occupancy, internal structures. You can have sensors there. Data collection or remote control, as we mentioned. Okay, there is a question, so I'm going to just quickly go over that real quick. Okay, maybe not. Okay. Sorry, it's hard to get out of the questions. Let's see. Dismiss. Okay. Sorry, I'm just getting out of this. Okay, so we're gonna get into, oops, sorry, let me just, there we go. So we went over some of the main benefits of IoT. So let's look at some actual technologies being implemented in smart buildings. So this is the INIQA tower in Vienna. It's equipped with heating and cooling systems automated on the outside temperatures. As I mentioned, there's weather systems coming into play, and it reduces their annual CO2 by 48 tons. It's one of the most cost-effective building operations in the world, which it's just, you know, it's a great example. We also have this building here in the United States. It's an MIT green building. They added sensors to detect internal damage. So they can use monitoring systems to see how the building is doing either outside or inside. And again, we use algorithms to make sure that there are no anomalies in the data. And that's when where we become intelligent as far as our understanding of the physical world. So could you imagine having all these sensors in an earthquake-prone region of the world? I happen to be from California, so having earthquake sensors in buildings would actually be quite phenomenal. There are lots of research projects out there that are doing this, and the idea is that these sensors take in movements from the earth, and they're able to give us an advanced warning system. This is just one way where we can use IoT in buildings to essentially for, you know, everyone's safety. which is quite phenomenal. And then we also have Deloitte's The Edge in Amsterdam. As I know, we've got some friends here from the Netherlands. It's the smartest building in the world, according to Bloomberg in 2015. It also has the highest sustainability score ever awarded, and smartphones know each worker's light and temperature preferences and adjust their room settings as one travels through the building, which is quite an, it's just, that's amazing. We also have the Siemens, the Crystal in London. It's also one of the most efficient buildings. It produces 70% less CO2 than comparable buildings. 70%, that is just a round of applause there. They do this by rainwater harvesting, black water treatment, solar heating, and automated building management systems. So the rainwater harvesting and black water treatment, essentially that's collecting water from the roof during rain events. Black water treatment is water that is used in the bathrooms that are being treated and being used back on site. Solar heating, which we can all presume is obviously going to be solar panels collecting energy from the roofs, and then the automated building management systems. Again, this is the data being collected in the actual building itself, and algorithms making the right adjustments based on your preferences for the actual building to reduce, again, that energy load, that water usage, etc. I also wanted to quickly discuss residential homes. I know a lot of us have at least one IoT device in our homes, and be it for energy efficiency, wellness, security, or smart assistance. And maybe that is controlling lights with your phone, having the app Ring. I know my parents have it. And then also having an Alexa. These are all smart devices, and they're always there for you to use to improve your life in one way or another. Connected homes also have a 31% growth in the market. So from 2015, 17 million, 2016, 22 million, and 16, 22 million, 2017, $29 million. So really this IoT world is not just in corporate buildings and building management systems and small buildings, but it's also the places where you sleep every night. And it's only going to become more ubiquitous, and then the market essentially is going to be responding to that. So it's also something to keep in mind is smart homes and in the residential areas. So what about old buildings and aging infrastructure? As mentioned, 2/3 of the world population will live in cities by 2050, and the buildings that we live in are going to be here for the next couple decades, if not longer. So how do we do this? How do we make an old building smart, right? What I just said. So we are working on a 3 million square foot government building. It is old. The columns are thick. We've got concrete everywhere. So how do we take this 100-year-old building and essentially get data from it? And the way to get data is obviously through connectivity. We need to be able to talk from the sensor to the gateway itself and have that sensor talk to the cloud. So we're going to be discussing our use case where we look at water pumps and elevator monitoring for holistic building complex, for historic building complex to understand the holistic energy usage of the building itself. So again, it's a 4 million square foot building. 100 plus commercial tenants work here, mainly manufacturing corporate companies. There are at least thousands of workers that are also here. And again, the building is 100 years old. It's on a 100-acre site, and it's steel reinforced concrete structures with a train and bomb shelters essentially in it. So this again is an old government building that we happen to be doing a smart building project on, and we're very excited about it. So the city, also this is a city-owned building, wants to improve on-site maintenance. They want better insights into equipment statuses, automated collection for elevator use data, preventative maintenance for water pumps, remote inspection for pumps pressure and temperature, and increased performance and operational efficiencies, and lastly, to reduce cost and environmental impact. These are a lot of us, but these are a lot of predictive and preventative maintenance issues that many building management systems, be it big, small, or medium, or utility scale, will be interested in, and is essential for the next wave or next decade or two of sustainability for these larger areas. So what needs to be connected? This 4 million square foot building has 8 massive water pumps. Each pump essentially has its own room, and it has a lead and a lead and lag pump, a tank, and what we call a PLC, which is a programmable logic controller. What that basically means, it's a brain essentially working in a machine that we can tap into to extract information. And then obviously these rooms, these water pump rooms are essentially in the basement, and they're about 300 by 1,000 feet thick with cement walls. So again, this is an old building that is meant to last essentially through, war, because there are bomb shelters there. So unable to get information from, again, a sensor or a PLC to a gateway, we're going to have to get through some concrete walls and thick pieces of steel. As far as the elevators are concerned, there are 25 freight elevators and 16 passenger elevators. They're located across the entire complex, and they differentiate between age, make, and model. So again, let's be real, existing infrastructure have different makes and models of every machine type, which way, that's fine, challenge accepted. We're able to creatively think on how to connect these old devices or new to a cloud service. So again, connectivity is the way that we get information from any sensor or machine. So how do we do it in an old infrastructure? Well, we're gonna use the internet, but we have to be very specific on how we do it. So there are connectivity challenges, one being that there is no internet at all. There, again, are thick walls, there are large machines and equipment. There are basement roofs and other dead zones being areas that do not have internet access, and the lack of available power supplies. I know somebody asked about battery sensors. This is where they probably would come in. And then IoT and staff concerns. IT being that, one, there are security issues that we have resolved and are currently always updating, and then staff concerns as far as, how does this work? How do I get the information that we need to, and how do I do it, again, in a safe, secure way that protects our machines and our overall building? So one is we try Wi-Fi, but don't forget we also have the Ethernet, that good old cable that's probably sitting in the back of your modem. We also have cellular options, and we can combine these methods as well. So we can do a variety of things. For this purpose, we are actually going to use a different wireless method. Again, we have Ethernet, which is that cord that you all have, again, somewhere at your house. We can also use different methods such as LoRa, which is just a different communication protocol, Zigbee, which is a different communication protocol, sub 1 gigahertz. So this is the radio frequencies, and this is actually what we're using for this old building. We're using this because Bluetooth, which we all have used Bluetooth, it's on our phones, on every laptop. It's a great way, but Bluetooth sound waves, if you will, only go a short distance, but sub 1 gigahertz, which is the radio frequency, the waves are a little bit elongated, and you can actually get through these concrete structures much easier, which is great. And then what overcoming connectivity challenges enables this use case. So by essentially connecting these water pumps and these elevator freights to the internet, we're able to reduce downtime for water pumps, which is essential, right? If there are only 8 water pumps in a 4 million square foot building, if one goes out, the other pumps are stressed. There may be a water leak somewhere, and this water itself is not going to get to tenants who need it desperately. And considering a lot of these tenants are in the manufacturing space, this water can be used to cool processes, to warm up processes. It's essentially, it's critical for their day-to-day functions. Predictive maintenance, as I mentioned earlier, once we have enough data, we're able to have a machine learning algorithm say, okay, in the past 3 months, everything looks good, but this one machine, maybe it's the water pump, it's not performing optimally. It's only having 70% of the output, but it's requiring over 100% of the energy, which means in 3 or 4 weeks, this machine will break. Again, this gives me time to order the piece that is going to break. I can also look at my subcontractor schedule to figure out a time when they can come on site with the machine part ready so they can fix it before the machine actually breaks itself, which is, again, what many building management systems, small or big, or utilities are essentially after right now. And again, the elevator data usage. So we want to figure out how many people are going to which floor. We do this in a really great creative way. We essentially take off the panel of the elevator itself, and we put an AC sensor that just picks up electrical current, and we're able to actually say when someone pushes floor 5, that electrical current gets sent to that input, and our sensor is reading that. So we're able to say, okay, floor 5 has been chosen, floor 3 has been chosen, floor 12 has been chosen. So it's a really innovative, great way that's essentially low cost that gives you the data information that you're looking for. Smarter repair scheduling, as mentioned with predictive maintenance, right? You can look at advance and figure out when people are available. We also have more efficient operation systems. Like I said, once you have information from your HVAC systems, your energy usage, maybe it's elevator usage, you're really able to figure out your entire energy load as far as where it's being distributed and used within your building. And then also keep in mind that IoT is as creative as you want it to be. If there is a specific data goal you're trying to solve, IoT is the arms and the thumbs that give you the ability to work with it. And so always keep in mind that there are smarter sensing applications that can be used as well. So some key takeaways when working with existing infrastructure, that they always require some creative or investigating ideas to essentially solve these connectivity issues. Don't be afraid to, again, combine combinations between using Bluetooth with radio frequencies or Ethernet, again, that cord that's in the back of your modem or, you know, some random cord somewhere in your house. You can always use these different communication protocols to get information that you need. Also know the details of how you want the smart building applications to be used. So if you're looking at energy usage just in water pumps, great. It's a clear cut example of what you're looking for. And we can essentially drill down and get that information. And then also, I'm gonna pick this up real quick since we're about to end. Connectivity issues. Also keep in mind the cost of benefit analysis as you learn about the energy usage and the water usage. Again, there are huge paybacks for having sustainability in these building management systems. And then keep in mind future applications of how you want to use IoT. So that is my presentation essentially about how to use IoT in existing corporate buildings, how we use it in residential homes, and how we use it in existing infrastructure. And then lastly, I'm just gonna go ahead and show you this air quality sensor, because I know having this term IoT, the Internet of Things, and implementing it into buildings is sometimes difficult to comprehend. So I'm gonna show you what we call this Nordic Sensor, and it's attached to this microcontroller and how it looks on a platform essentially. So you guys can essentially see that. Let's see. Oops. Let's stop video. Oh, sorry. Let me. Okay, well, this is, again, the sensor itself, the microcontroller, and the cloud-based platform. And this is what it looks like on your laptop. So I just have one deployed here in New York City, which is where I'm at. This is the air quality sensor. So I currently have it in the office that I'm in, and it's taking in information, as we can see. So these are the tiles. Right now, I turned it on at the beginning of this discussion, and it's reporting every 30 seconds. You can also just have your cursor over it. So it's 79 degrees in this office right now. You can see the different pressure, you can see the humidity, and you can see the CO2 levels. So this is all based on one little sensor that fits in the palm of your hand. If you want to ever download the data, you can just download it here, and it comes to you in a CSV file. You also have the minimum, maximum, average temperatures, depending on which graph you're looking at. And you can see what the data looks like over a period of time, depending on how long the sensor is actually on. So I just kind of wanted to show you a little bit of, you know, you can have these sensors in a building and collecting all these information. It doesn't have to be a huge sensor. It can be something very small. You can get data very quickly. So again, I turned this on at the beginning of this discussion, and this is the data that we have. So I think I have about 13 minutes for questions. By all means, feel free to ask, and thank you for your time. I appreciate it, and I hope it was informative and how we can use the Internet of Things to essentially get smart and healthy buildings.